Hi, welcome to single source shortest path problem, which is used to find shortest path from any source vertex to all other vertices in the given weighted graph. For example, here if you select vertex A is the source vertex, then from this source vertex you have to find out the path to all the vertices which is available in this given graph. You should not leave any single vertex without connecting with, without having the path from the source vertex. Suppose if you take vertex C is the source, this from this C you can visit the A, you can visit the F, from the A you can visit the D, then from the D you can visit G, from the G you can visit F, but it is forming the cycle. That should not form the cycle. Okay, so you can visit all the vertices from any vertex that you are selecting as a source. Then we have to use to visit other vertices by using the weighted edge, the minimum weighted edge. So whenever you are selecting a path to visit the neighbor, adjacent vertices, so to visit that adjacent vertices you have to select the minimum weight, then only your path cost will be less. So when you are calculating the total cost, that should be less when minimum weight of all other paths. Here, for finding the single source shortest path to all other vertices, we can use uh, a breadth first search algorithm for unweighted graphs. Here, each edge can be considered as to have unit weight. Suppose if there is no weight is given to the graph. Suppose if I am having 1, 2, 3, here I am having the undirected graph. In this undirected graph I am not having any weights. If weights are not given, then we can use the unit weight equal weight to all the vertices, all the edges. And Dijkstra's algorithm is used to find shortest path on weighted directed graph. So you look at here, this graph is having weights to all the edges in the graph, and also yeah, the edges are directed to unidirectional, which is not a bidirectional, which is unidirectional edges. So that weighted directed graph is called unidirectional edges. So here the Dijkstra's algorithm will not work for non-negative, negative weights. So the weights which are given to the edge should be non-negative. Always the edge weight should be a positive value for Dijkstra's algorithm. So whenever we are finding the single source shortest path in the given directed graph, we should use positive weighted edges. We should not use negative edge, for example -9, -5. So this value should not give for the uh, Dijkstra's algorithm single source shortest path problem. And we can use a DFS, also depth first search algorithm, for finding the shortest path from any source vertex to all other vertices. Here we can use this single source shortest path algorithm for different applications. First one is maps. So here for example Mapquest, Google Maps. So here we can use any source. From the source we can visit any location from that particular source. So that we can use this algorithm, single source shortest path algorithm, can be used for finding any location by using the shortest path. And also network routing system. In the routing, we can use, look at here, different networks are there. This is one network, this is network 2, this is network 3, network 4. In between we are having the routers to route the uh, data from one network to another network. So here, to select the shortest path to reach this network, any system, suppose if I want to pass the data from this one to this computer, then we can select the shortest path uh, by using the DFS algorithm or Digistra's algorithm. So single source shortest path algorithms are used to finding the shortest routing in the computer networks. Thanks for watching.